Okay, so Unit 9, questions 28 to 30. If you can please look at Unit 9, questions 28 to 30. So if you can read the passage and look at the question and see if you have some sense as to the answer to the first question. Okay, so the first thing that I would like to hopefully remind you of is that is why logarithms exist. Why would you think logarithms have been created? Yes, the answer is yes. It is second. It is a second order reaction. The reaction which I wrote there is second order. Okay. The question was about this, and this is second order reaction because the exponent here is 1, the exponent here is 1, 1 plus 1 is 2, making that a second order reaction. So I just have to remind you of this fact of why logarithms have been invented, because let me say, it's almost impossible that you're going to sit the GAMSAT in March or in September and not have a question that involves logarithms. Logarithms comes up in physics, in chemistry, both general and organic chemistry, and yes, logarithms even comes up in biology questions. So it comes up very frequently. Your ideas and concepts of logarithms have to be very clear. Now, the reason they were created is to change something that is increasing at such a fast rate, exponentially, into something that is increasing at something that is linear, that's easier to handle, easier to watch, easier to deal with. So, so the log of 10 is 1, okay? The log of 100 is 2, log of 1,000 is 3, 10,000 4, and so on. And so this is following very, very basic logarithm rules. So the first question is, let the rate of the reaction at pH 3 be R if all the variables are kept constant except that the pH is changed to 2, then what is the new rate of the reaction? So what's the answer here? The pH is going from 3 to 2. How much is the hydrogen ion concentration changing? That's exactly it. Now, if you're going from pH 3 to pH 2, you say it's tenfold, but is it 10 times higher or 10 times lower? If you go from pH 3 to pH 2, is the hydrogen ion concentration 10 times higher or 10 times lower? Right. pH is decreasing, so hydrogen ion concentration is increasing. And the reason is because pH is equal to negative log of hydrogen ion concentration. Sorry, I'm not as fast at typing, but so, and what this says, okay, is that because of this negative sign, not because of the logarithm, because of the negative sign, when pH goes up, hydrogen goes down. When pH goes down, hydrogen goes up. That's because of the negative sign. That has nothing to do with the logarithm. The purpose of the logarithm is to straighten out the curve. And because of that, if you have something that is 10 times, a change in 1 unit, pH 3 to pH 2, it means it's a factor of 10. Had it been a change in pH units of 2, it would have been a factor of 100, and 3, 1,000, etc., etc. This is a frequent type of question, and yes, as you said, the answer is B, and which is 10 times, because the pH changed by 1. Okay, so question 29. Now question 29 shows a table. And the table has 3 experiments and shows the different concentrations of R and S. And then, so what we would do normally is you would write what the general equation is for the reaction. And the general equation for rate law is that the rate would equal K, which is a constant, and then, of course, you know, the square brackets stand for concentration, which is in moles per liter. So then you would write the concentration of R and the concentration of S. And this is the general rate law for the equation. But we need to determine what the exponents are of the rate law. So what would be the exponent of R and the exponent of S in order to determine what the true rate law for the reaction is. The only way that you can find what the exponents are is not by looking at the coefficients of the reaction. Okay? This is not like an equilibrium constant or KSP, which is the solubility constant. It's not like that. You can't look at the exponents of the coefficient of the reaction and then use that as exponents. In order to know what the exponents are for the rate law, you have to get evidence. You need an experiment, and you have some sort of table, and then you can interpret the data from the table. And so the interpretation is quite basic. So we look at the experiments, 1, 2, and 3. So we can begin by looking at comparing experiments 1 and 2. In experiments 1 and 2, the concentration of R remains unchanged. It stays at 0.1. However, the concentration of S is doubled. When you double the concentration of S, the rate of the reaction remains unchanged. So by changing S has no effect on the rate. So the way we interpret that is we put the exponent as what? What would the exponent be? Remember, doubling S has no effect on the rate. So if it has no effect, the exponent would be 0. Yeah, so it would be 0. See if I can put 0 there. Okay. So the rate, the exponent of S is 0. Now, anything to the power of 0 becomes 1. So it means that this is completely knocked out of the reaction. By the way, because it's to the exponent of 0, we say that the reaction is 0th order with respect to S. Not first order, not second order, but 0th order with respect to S. Okay, now we focus on R. We want to find out what the exponent is for R. So in looking at the experiments, we look at experiment 1 and 3. We see that if you double the concentration of R, but you keep S constant, then the concentration of the rate is doubled. Not the concentration, but the rate is doubled. So we find from the data in the table, if you double R, you double the rate. So that means that the exponent here for R is just 1. And if you put a 1 there, it's the same as not putting anything at all. You don't have to put a 1 as an exponent because that's the same as not putting anything. So yes, because it's 1 as an exponent for R, it means it's first order with respect to R. And actually, it's first order for the entire reaction because S is 0th order. And to know what the overall rate of a reaction is, or order of the reaction, you add the exponents. So you would add 1 plus 0 is 1. So it's a first order overall reaction. And you can say first order with respect to R and 0th order with respect to S. So the answer would be A. Yes, the answer would be A. Now, just talking generally speaking, what is the order of the reaction of answer choice C? Right, it would be a second order reaction because the exponent is 2. Now, what is the order of the overall reaction of answer choice D? That's right. Answer choice D is a second order reaction. In fact, and don't get tricked, because sometimes they won't say it's a second order reaction. Of course, they can just say, if you had a reaction which was first order with respect to R and first order with respect to S, what is the overall rate of reaction? Of course, it's second order reaction. They'd find a more trickier way to say it, but it's important for you to be comfortable with the different ways they can present information. And answer choice B, what is the rate of the reaction, the overall order of the reaction? Answer choice B, what is the order of the reaction? That's right. It is a first order reaction because it's dependent on the exponent. It's not dependent on what's inside of the brackets. It's dependent on the exponent. Okay, done. So question number 30. Which of the following graphs represents a first order reaction? Okay, just to let you know, this type of question in question 30 is both actually 28, 29, and 30 are all types of questions that come up relatively frequently, so you have to be very comfortable with it. So the first thing I'm going to do is I'm going to manipulate something the equation that you were provided with is a logarithmic equation that comes down to this: x and t, and that's equal to kt. Okay, so you need to know your basic rules of logarithms, and if you have a logarithm in which two things are being divided, it's the same thing as they are being subtracted. If two things are being multiplied of a logarithm, it's the same thing as they're being added. So can everyone recognize the equation that I just typed? So ln is a logarithm to the base e. It follows the same, e is, it follows the same rules as logarithm to the base 10. So either, whether it's logarithm, which is, this is the natural logarithm, whether it's to base e or base 10. And e is an irrational number. It's like pi. You know, pi is 3.14159, blah, blah, blah. Well, e is 2.7 something, whatever. So e is an irrational number, but it works. It's very important in nature, obviously, and that's why it's called a logarithm to the base e is called the natural logarithm. But it follows the same rules as just log. When you see log by itself, it means that it's to the base 10. Okay, so I've written the equation in a different way. Now, please think about this, because I can't retype it every which way, but think that I am going to multiply through by -1, and I'm going to isolate logarithm of xt. So here I'll do that. And I'm multiplying through by -1, so I'm going to get -kt, -kt. I would have made the other logarithm negative, and so now it's going to be positive on the other side. Concentration, x, and then, oh, and I'm sure some of you are wondering, why multiply by -1 and why isolate anything? And it's to remind you of this high school equation that you once mastered. No matter if you have a science or non-science background, you once mastered this equation, and it's y is equal to mx plus b. And the meaning of this equation is that m, of course, is the slope. And the slope is rise over run, which means delta y over delta x. Yes, the gradient is another way to call it. And b is the y-intercept. So that's where the line or curve will intercept the y-axis. So I rewrote the equation that they provided in this way so that you see that if you have y versus x, so a graph of y versus x, which would be ln x versus x, which would be t, then you would get negative k as the gradient or slope. Negative k means negative, means the slope is negative. That means it's going down, okay? A positive slope is going up over time. This is going down because it's negative. And k means the slope is constant. That's also important. The slope is not continually changing like you would have in a curve. The slope is constant like you would have in a line. And this is the classic equation for a line. And then this would be the y-intercept. So then in looking at the answer choices, we see that only answer choice C presents ln x, the natural log of x, versus t, that's the x-axis. And the slope is a straight line, constant, and it's negative going down. And this would be the y-intercept, which we don't actually see, but we can predict. So answer choice C has to be the correct answer. Answer choice A would be what order reaction? Because we're looking for first order reactions, so the answer is C. Answer choice A would be for what order of reaction? Actually, and yes, unfortunately, you do have to know this, okay? Because this does come up from time to time. Okay, consider this. Consider that when chemicals are reacting, because don't forget, we're looking at what happens to the reactant over time. When chemicals are reacting, I think it's easier to imagine a second order reaction where it takes two chemicals to react together. Do you think that the rate that the reaction rate over time is always going to be the same when you have two things reacting together, or do you think the rate will occur very fast at the beginning and then increasingly slower over time? What do you think? Okay, imagine Shanghai. Shanghai has a population of 30 million people. 30 million people, that's like the entire population of Australia at plus 50%. Okay, so 30 million people in one city. Imagine that the reaction was two people bumping into each other. So anytime you have two people bumping into each other, they completely disappear. Okay, so the reactants disappear and you have products. But imagine, two people bump into each other, they completely disappear. So my question is this: will the rate of disappearance of the reaction be constant during the reaction, or would you expect it to be so much at the beginning and then over time it's so much less? So the rate is increasing at and faster and faster the rate is decreasing of the reaction, or is it constant? Yes, it would be incredibly a lot at the beginning. People would be bumping into each other at the beginning, but then just minutes later, because if everybody who bumped into each other disappeared, every time you had two people disappear, then later it would be so fewer of that reaction. And that's why if you have a second order reaction, the rate would start off very, very fast, but then it would be less and less over time. like that. And just so that I'm very clear about what we're drawing here, this is just the concentration of X, and that's over time. Okay? So, and I keep talking about rate, by the way, when I was talking, because I'm talking about the slope. The slope gives the rate, because don't forget, rate is the gradient, which is the slope, and that is delta y over delta x. So that's a concentration over time. And rate in science means over time. That's what it means. Anytime you hear rates in science, they're talking about over time. And so over time, the rate is going less and less. The slope is starting very high, and then less and less. If this was that's for a second order reaction. If this was a first order reaction, the same idea happens. It is curved. The curved is not as strong, but it is still curved. So what does it look like to have absolutely no impact? That the reactant has no impact over time. That's what it looks like. Constant. So the elimination of the reactant is just constant over time. And yes, so that makes it a zero order reaction. So A is zero order. C is first order. B makes no sense whatsoever, because B is showing that over time, the reactant concentration is increasing. Actually, not only is it increasing, it's increasing in exponentially way. You know, so it makes no sense. You can't have more and more reactant. You're getting more and more product over time. And D also makes no sense, because it's the logarithm that straightens out curves. And because it's a logarithm of a concentration, we expect a curve to be straight. So, okay, so that settles 30.